speaker Mykola Ivanovich Portenko, and he will speak about stable processes with reflection. So let's go.
Okay. Okay. Hello, everyone. I thank you for coming here to listen to my talk, and I would like to start my lecture. Okay. To begin with, I would like to recall some basic notion. For fixed parameters. Oh, okay. This is my first lecture online, and I will try my best. For fixed parameter alpha from the interval 0, 2, and C positive, we define the function g, t, x, y being equal to 1 over pi integral from 0 to infinity e to the power minus c t c to the power alpha cosine xc x minus y dx, where t is positive, x is a real variable, and y the same. It is not difficult to verify that this function takes on only positive numbers, only positive values, and the full mass, the integral over r with respect to y, with respect to Lebesgue measure, is equal to 1, and this function satisfies the Kolmogorov-Chapman equation. So there exists a Markov process. I will denote it by x of t, mt, px, such that the probability that x of t takes on its value in the set gamma is equal integral over gamma of gtx y dy. And it is true for any t positive, any x from R, and any Borelian gamma. Gamma belongs to sigma algebra of all Borelian subsets of R. Moreover, this Markov process can be treated as a standard Markov process. There are 4 cases that are distinguished in this theory. Alpha, the first one, alpha is a number between 0 and 1. 1, alpha equals 1, alpha between 1 and 2, and alpha equals 2. Phi is a scaling parameter, so the main properties of the process are determined by the value alpha. Two stable process is a kind of Brownian motion. If additionally C equals 1/2, then this is a standard Brownian motion, and it is well described in literature. If alpha between 1 and 2, in this case, as well as in the case of alpha being equal to, there exists local time for the corresponding process. And this is one cause why I am going to consider the case alpha from the interval 1, 2. Okay. Now I would like to talk about reflected. I would like to say that this process, exactly this process, is called a symmetric alpha stable process. Okay, and I would like to talk now about the reflected alpha stable process. As you know, reflected Brownian motion, a reflected Brownian motion, a reflected Brownian motion is the same as the absolute value, the absolute value of Brownian motion. And its transition probability density can be written as follows: G T X Y plus G T minus X Y for T positive, X non-negative, and Y non-negative. This is the transition probability density of the absolute value of Brownian motion. We can consider such a function in the case if when alpha is a number from the interval 0, 2. This is the transition probability density of the absolute value of alpha stable process. Okay, I would like to denote. Oh, okay, and the problem is to characterize the process. How to characterize the absolute value of Brownian motion or absolute value of alpha stable process, symmetric. It is well known that if you subtract from the absolute value of Brownian motion its local time multiplied by 1/2, then you obtain some new Brownian motion, and therefore you have some stochastic differential equation for the absolute value of Brownian motion. Is it possible to describe the absolute value of of absolute value of alpha stable process in in a way similar to that description valid for Brownian motion. And I would like to formulate my very old result, a result of 1997, but I have first to introduce some notation. Fix okay, fix the parameter Q it's fix the parameter Q. Oh, okay. From the interval -1, 1, and consider the following function. I denote it by G capital T x y that is equal to G T x y plus Q sine of y G T minus absolute value of x, absolute value of y. Here T is positive, x is a real variable, and y is also a real variable. Q is a fixed parameter, fixed number from the interval -1, 1. It is not difficult to verify that this, and G is the function defined by that integral I wrote it before. Okay. It is not difficult to verify that this function takes on only non-negative values, and the full mass of it is equal to 1, and it satisfies the Kolmogorov-Chapman equation. So there exists a Markov process with this function as transition probability density of that process. Okay, I denote it by x of t, x capital of t. And it turns out that, oh, okay, I would like to say first that
This is for
the part
Brownian
of,
motion.
excuse me?
Nikolai Ivanovich, this is for the case of Brownian motion or for general case?
For general case.
Mm-hmm.
And including Brownian motion,
Yeah.
including alpha being equal to x of t is the process with this transition probability density with respect to Lebesgue measure. And you see that the part of this process on the interval 0 plus infinity is exactly reflected, symmetric alpha is exactly a symmetric alpha stable process reflected at 0. That is its part on that interval 0 plus infinity is the absolute value of alpha stable process. Okay. And
Nikolai Ivanovich, let me ask you again, what does it mean part of the process? What do you mean?
You can, if if you consider the probability for x positive, then the probability that x of t is positive is always equal to 1 for positive x, okay? And its transition probability. So you can consider this process as a process on positive, on non-negative semi-axis, okay?
I see. Okay.
And its transition probability density is exactly GTXY plus, I forgot to say that Q, in the case if Q equals to 1, in the case of Q equals 1, its transition probability density is equal to GTXY plus GT minus XY. And this is exactly the transition probability density of the absolute value of corresponding alpha stable process. Okay.
Thank you.
The part, this term was used by Dinkin, the part of the process. If there exists some subset in phase space such that the process does not leave.
Do you use, Nikolai Ivanovich, do you use only symmetricity of xt? Probably this is true if xt is symmetric Levy process.
Yes, yes. The main property that used here is symmetricity. Symmetricity, yes. Okay. And my old result in 1997, I proved that this process can be characterized in the following way, as the solution to the following martingale problem. If we have function f such that it is twice continuously differentiable and bounded along with its derivatives, then f of x of t minus f of x of 0 minus integral from 0 to t L f of x of s ds, this process is a martingale. Oh. A martingale. Martingale. It's a martingale where L is the following operator. L acts on such a function in the following way. A of x f prime of x plus integral over r f of x plus y minus f of x minus y f prime of x f prime of x multiplied by pi x y pi dy, where the function a of x is given by the following expression: 2c over pi gamma of alpha minus 1 sine pi alpha over 2 absolute value of x minus alpha plus 1. I would like to pay your attention that a of x is something like drift coefficient. And you see, this function has singularity at the point x equals to 0, x equals 0. And this singularity is not integrable for it is not integrable for any p that is greater than 1 over alpha minus 1. It's not integrable. So there are some results that alpha stable process can be perturbed by the drift that are integrable in the following way. There exists some p greater than 1 over alpha minus 1, and then such a perturbation is possible. But here we have not integrable for any p, for there is no p satisfying this inequality, that this function is locally integrable, okay? And pi capital dy is the Levy measure for the alpha stable symmetric process. It is given by the following expression: C or P gamma of alpha plus 1 sine P alpha over 2 absolute value of x to the power minus alpha minus 1.
Maybe y.
Y. This is what I would like to write: y dy. Okay? And the function pi x y could be written as follows. It depends on Q, on alpha C, okay, and no, C, it does not depend on C. P pi Q X Y is equal 1 minus Q, indicator minus infinity minus x of y plus double y plus 1 plus q absolute value of y over y plus 2x to the power alpha plus 1 indicator minus x plus infinity of y if x is non-negative. And something like that, but not the same if x is negative. So
Mykola Ivanovich, you have here Q, and is Q 1 for reflected?
for reflected one, yes.
And for other, Q is just number, which is less than 1, between
Yes,
minus 1 and 1.
Between minus 1 and 1, yes. So, okay. So this is the characterization of the process x capital of t, which is defined by, which is defined by the transition probability density G capital, but I cannot find it. G capital. Oh, yeah. G capital is defined by this formula for any Q from this interval, where G is defined by the integral.
And Mykola Ivanovich, one more question. I forget. If Q is less than 1, then this transition density is not, so it is non-negative. The question is it non-negative?
Yes.
Mm-hmm.
Yes.
Because of unimodality of this.
Yes. Because alpha stable distribution is unimodal. It is not difficult to see that unimodality makes that function take only non-negative value. Okay. Now, there is some other way to construct reflected. The other way to construct alpha symmetric alpha stable process reflected at 0. That way was proposed by Kiyoshi Ito, as far as I know, not later than 1962. He proposed to transform the trajectories of the symmetric alpha stable process. So let x of t be alpha stable symmetric process. Define the following stopping time for this process. Sigma is equal infimum of those s for which x of s is less than or equal to 0. Professor Shinzo Watanabe in 1962 showed that this stopping time had the following property. The probability of the following event, there exists some t from the interval 0 sigma, including sigma, such that x of t minus equals 0, this probability equals 0 for any positive x. It means that the distance from the following set 0, one of these sets is 0, and the second one is the set of all values of the process if S belongs to 0 sigma. This is sigma. Okay. Distance between this set and that one, this one. This is, is positive with px probability 1 for any positive x. So 0 is not a limit point for the value of the process on the interval 0 sigma, including sigma. Okay, and now we can construct the process, the alpha symmetric alpha stable process reflected at 0 in the sense of eta. X hat, I denoted by x hat of t, it coincides with x of t if t is less than sigma, and it is equal x of t minus infimum over all s between 0 and t, x of s, if t is greater than or equal to sigma. As you see, the process x hat of t takes on only non-negative values. Okay? It can be found in, for example, in the book by Bertrand devoted to Lévy processes, that this process x hat of t is a Markov process. And its transition probability density can be calculated in the following way.
Nikolai Ivanovich, can I ask you such question? This statement that x with hat is Markovian is based on the precise formula for the density of Lévy process, or it can be generalized for some other Markovian process?
This proof uses the fact that x of t is the process with stationary independent increments. And this is not difficult, not so complicated.
Yeah, it was my question. So it is not only for Levy process, yeah?
Yes.
Actually, this is Skorokhod map in modern stochastics. So this map.
Yes, but it is for discontinuous functions, yeah?
Yes, so Skorokhod map for discontinuous, but the formula is the same.
Yeah.
And
okay.
probably all properties are also the same.
Yes.
So it was my question, actually. Yeah. Thank you.
Okay. So I would like to calculate formally. I write it formally because I do not know whether there exists transition probability density of this process.
But if it exists, it must be.
If it exists, I denote it by G hat. G hat T 0 Y. I would like to write down some formula for this. In fact, we can use only integrals from this density, so we can calculate in fact that the probability that the process x hat of t takes on its value that is less than z. For z non-negative and t is greater. Okay, so I would like to introduce firstly the function g sigma of tx y. Consider the following probability. Why? Well, the following probability. Probability that x of t, that is a symmetric alpha stable process, belong to the set gamma, and sigma is greater than t. Okay, it is evident that this function is absolutely continuous with respect to gamma, with respect to Lebesgue measure. Okay, and if I denoted density by g sigma txy, so this integral is, this probability is equal to integral over gamma g sigma t x y dy. And this function is not so bad. It was observed by Daniel Ray in 1958 that this function is continuous in t and y. It follows from the following representation, from the following formula. gtxy is equal g sigma txy plus integral from minus infinity to 0 pi x ds dz g t minus s z y, where pi x ds dz is the joint distribution for sigma and x of sigma. I think that this formula is evident. Okay, how the process goes from x to y during the interval of time from 0 to t. It does not visit the interval minus infinity 0, or there is some instant of time when it for the first time visits this interval, and then during the time from 0 to t minus s must be it must go from z to y. Okay, and you see this function is continuous with respect to all its argument, because it is given by the very well convergent integral. Okay, and this function is the same, continuous with respect to t and y. So this function is also continuous with respect to t and y. And the following property of G sigma should be mentioned. This was proved by Shinzo Watanabe in 1962, that the function G sigma txy is symmetric with respect to the argument x and y. It is evident that GTX y equals 0 if x is less than or equal to 0, or y is less than or equal to 0. Okay, G sigma, excuse me. I'm sorry. Okay. So this function is symmetric. It is very interesting. This fact is very subtle, and proof is not trivial. Okay, now, oh no. Oh. Now, now I would like to pay your attention to the fact that during distribution of the x of t and x of t, I would like to write down x of t and infimum over 0 over s between 0 and t, x of s joint distribution of these two random variables can be expressed through the function G sigma. It is very easy because this probability is the same that probability starting from the point Z. Here Z is non-positive number. This probability is the same as the probability starting from minus Z. X of t belongs to gamma minus Z, and infimum X of Z is strictly greater than 0. It means that sigma is greater than T. This is S. Okay? And it can be written as integral over gamma minus V G sigma T minus V y dy. And it can be rewritten as follows: integral over gamma G sigma T minus Z y minus Z dy. Okay, so the joint distribution with respect to measure P0 of these random variables dy infimum over S between 0 and T, X of S belongs to dz is minus d dz g sigma t minus z y minus z. Okay, minus because this function is not the distribution function. Okay, and this derivative is formal, or it can be considered as the derivative in the sense of distribution or generalized functions. Okay, so we can, if we know joint distribution xt and infimum, and this infimum, so we can write down the distribution of x hat of t as integral of this this density of joint distribution. So minus d dz g sigma t minus z y minus z dz dy, and you should integrate over the region dA, which can be described as follows: dA consists of yz such such that z is negative, is non-positive, y is greater than or equal to z, and the difference z minus y should be less than a. You see, you should integrate this function, and one of these integrals have already been calculated. You should omit this sense, and it is very easy to it is very easy to calculate. Where is my d? Oh, yes. No, I cannot find out. Maybe this. Oh, yes. It is very easy to integrate, and we have the following formula: g hat t 0 integral from 0 to a g t0 z dz y dy is equal to integral from 0 to infinity g sigma t a y dy. We use here the symmetricity of this function, and some more complicated reason show that in the general case, we have the following formula: g hat of tx y dy is equal to integral over x from x to infinity g sigma t a y dy. And now I would like to pay your attention that it turns out that this function g, no, maybe not. I would like to pay your attention to the following fact, that the probability that x hat of t is less than a coincides with the following probability. Probability that supremum over O s from 0 to t, x of s is less than a. Why? Let us turn our attention to this integral. This is the probability that x of t belongs to the interval from 0 to infinity, and sigma is greater than t. But if sigma is greater than t, then x of t, of course, is a number between these numbers 0 and infinity. Okay, so this probability, in fact, is equal. This probability, in fact, is equal to the probability that starting from a, sigma turns out to be strictly greater than T. And the probability that sigma is greater than T is equal to the probability that starting from 0, supremum over all s between 0 and T x of s is less than A. It is very easy to see that, because what does it mean? That infimum is greater than 0 if starting from A. It's the same that infimum, that if a process started at 0, infimum greater than minus A. And because our process is symmetric, this probability is the same as the probability starting from 0, supremum is less than A. Infimum is greater than minus 0. The same that supremum is less than A. And this probability, for this probability, there are some formula. For example, formula Rogozin-Spitzer. We know that the integral from 0 to infinity e to the power minus lambda t, integral from 0 to infinity e to the power c y d y, the probability that sup of x of s is less than y, excuse me, y dt lambda, this is equal x k plus lambda c, where k plus lambda c is equal integral from 0 to infinity e to the power I c y minus 1 pi lambda of y dy, where lambda is positive, c is a real variable, and pi lambda of y is determined as follows. It is the integral from 0 to infinity e to the power minus lambda t gt0y dt over t, where g is defined at the very beginning of my lecture. Okay, so you see this distribution is determined by the distribution of our process with the help of this formula. Okay, but I know that this is the probability that x hat is less than A. So I can write down that the probability that x hat of t is less than A, less than y, integral from 0 to infinity e to the power minus lambda t dt is equal the following formula: 1 over 2 pi lambda integral from minus infinity to plus infinity 1 minus e to the power minus e psi y over e pi phi x k plus lambda phi dik phi. Sorry, dik phi. And I feel that my time is over. I write down the last formula.
Okay.
It is not difficult to find out the following property of this function: 0 e to the power minus lambda t p0 x hat of t is less than y dt is equivalent if y goes to 0, y to the power alpha over 2, and some constant, some positive constant. What does it mean? It means that this function, that the density, this density has singularity at the point y equals 0. You see, if this function is bounded at that point, so we have here y to the power 1. But now alpha, I consider alpha greater than 1 and less than 2. So we have that this probability has not the first order as y goes to 0. So this function has the singularity, and that singularity is of this order.
For fixed t.
Yes.
Okay.
For fixed t.
Excuse me.
For fixed t.
T is fixed now, or
this is
no,
this is Laplace transform.
okay.
You see, this is Laplace transformation of this function. So Laplace transformation of the density has the singularity, and it is not. I think that this process have no local time at 0.
Nikolai Ivanovich, actually, as I understood, Andrei asked about the property of the density itself, and
This G hat.
Yes, G hat, and it can happen maybe that density exists, but it blows up when t goes to 0. And in this case, we will have some singularity with respect to y, maybe.
Yes. You are right. You are right.
But for fixed t, still it means that it cannot be uniformly bounded with respect to t. Yeah, something like this.
The result is this.
Yes, yes, I understand. Yes,
The
but
result is this. This is very exact result. This order is y to the power alpha over 2. This means that the Laplace transform of the density has this. So Laplace transform is of this density is the Resolventa kernel. Okay, so Resolventa has the singularity at the point y equals 0. And I have some more properties of the process x hat, but it is not convenient for me to have my lecture on this in this way. Just 1 second. Thank you for your attention.
thank you very much, Nikolai Ivanovich. Nevertheless, it was your first time with tablet. It is very clear and interesting explanation. So if anybody have comments or questions, please.
I have a question about the local time. Maybe the local time in the sense when you divide by, when you calculate the time spent in interval 0 epsilon and then divide by epsilon does not exist, but the local time as Blumenthal-Gettur local time, it might exist.
Yes, I think that I think that it exists if you divide not on epsilon, not by epsilon, but epsilon to the power
To some power.
To some power, yes.
Please, another questions? Nikolai Ivanovich, I have the following question. You constructed the first process, which you called reflected Levy process, and this process X with hat. But the description of these two processes was built in different terms. For one, you propose density. For another one, just Laplace transform the density and so on. Can you compare these two processes calculating generators or something similar? For example, generators, resolvent for these two processes and so on.
In the paper by Watanabe in 1962, I mentioned it before. The author established that the process X hat of T has the same generator as alpha stable process, symmetric alpha stable process, but it must satisfy some boundary. It must satisfy some boundary condition, and that boundary condition is as follows. If you consider a function u of x, you should consider this ratio and take the limit as x goes to 0 plus, denoted by delta u, and the boundary condition is delta u equals 0.
This is like
like the normal. If alpha equals 2,
yes. This is
then here we have normal derivative. Well, not normal, but derivative, the first derivative, okay? What the first derivative is equal to 0 means the instantaneous reflection. And the same here, but you see the boundary condition is of this type.
Interesting. Okay, thank you.
But generator is not the same as for Lévy alpha stable, but truncated a little bit. Is it correct? When you integrate not from minus infinity to plus infinity, but you have to integrate.
This measure P, yeah?
Yes. I forgot. Yes, it is the measure P, the measure pi is, I forgot. I afraid that I can say something wrong.
Okay, let's postpone this question for other time. Maybe some other comments, questions. Okay, if there are no any questions else, then thank you very much for interesting talk, and goodbye everybody up to the next week. Bye.
Thank you. Bye.
Thank you. Bye.